let's.
Yeah, I see here one question here that is asking here larger area modules. Pardon?
No, I'm just wondering if you could actually type them. Actually, if you could
not hear you very well.
But maybe you could type them in, Marcus, the question in the chat function, so that we continue with the conference and you might actually answer. Everyone is reading that. Okay, so then let's continue with the next speaker. So also very, very happy to have with us Dr. Peter Fath. We know each other for decades, and to introduce him or all what he has been doing in the solar industry would take a little bit longer. So I just mention the most recent things he has been doing and he's been active in. So I think two of the jobs he's been having, he's representing in today's conference. Peter is the Chief Technology Officer of Kalyan PV, Europe's only wafer module manufacturer today, which is fairly new. And what he did is actually he designed that with his company RCT Solutions. Those of you who are longer in the industry probably know also Peter from one of his previous jobs when he was the CTO at Centrotherm, which was the company that has been providing much of the thermal equipment several years ago that was used to design cell factories, especially in Europe, but also when the big wave started in China. Today, Peter will talk to us about the design and of cost-efficient new vertical integrated PERC module production facilities. So he will, I already mentioned that, share hopefully as much of his learnings from building the Kalyon factory in Turkey. Peter, the floor is yours.
Thanks a lot, Michael, for your so kind introduction. I didn't know that I'm getting so old that there is a long list to tell about me. So then I will start my presentation. Is it visible?
Yeah, perfect.
Okay, so as we learned from Marcus, and especially his last slides, we have to hammer a huge amount of factory capacities to the ground. We have to increase our global capacity by hundreds of gigawatts. So that means we need to know how to hammer a factory into the ground and how this factory should look like. And of course, we can not only rely on our Chinese friends. They're saying they will do the job, they will make these hundreds of gigawatts of new factory capacity. There might be companies like Kalyon who says, I want to do it also outside China, outside Asia. So now let us look how we can do it, my friends. So first of all, quickly, RCT Solutions, what we guys are doing. We are owners, engineers. We are setting up factories globally, and we are supporting companies who want to say, I want to have a 1 giga, 5 giga, 10 giga factory. And they come to us and we do it together. And on the other side, we also have RCT Power, which is a storage company. So we have factories in China and soon in Mexico, preparing container-based storage and batteries as well. So now, technology, PERC. I have to focus on PERC, as Michael said to me. So first of all, we can say PERC is a mature technology. It's working. And it's available on all different wafer formats from N10 to G12, M12. Also, we have solar cell production tools available. We don't have to reinvent the wheel and finding some new coating machines. The mature production tools available, including automation, including factory automation. for different type of wafer formats. And then also, based on PERC technology, we have a wide range of modules available from residential, commercial to power plants. So we can say, based on the statistics, you see PERC and TOPCon as a package will dominate the sector for another 10 years. So that is the right choice of Michael to ask me to talk about PERC factories. So, but if you set up a PERC factory, but you want to benefit from improvements, of course, you can use PERC line, PERC equipment, PERC ingot factory as a base. And at a later stage, you might say, I want to go into TOPCon, I want to go in IBC, and you just upgrade your factory. Either you do it immediately at the planning of the factory, you just keep some space reservation, or you even implement perhaps one TOPCon line, one IBC line at the very beginning. So that means if you run for PERC, you're not lost and you will benefit from future improvements by just upgrading your production line accordingly, adding some machines, some lasers, and it's done. So, as I mentioned to you, if you want to go into a product diversification from the very beginning, you say, I start with PERC, but you, of course, I say to you, you can also have a kind of a flexible factory. You say, I want to have this premium market segment access, which is perhaps a TOPCon or the IBC base, and you can even share some of the production equipment. You can make IBC cells or TOPCon cells in the same type of factory as the PERC. So that means from your product portfolio and future improvements, you're not limited. So this is a beautiful product portfolio which you can make in your PERC-based factory. You can make residential products, 400 watt peak modules, 108 cell, M10, whatever you want to do. And of course, you can go to power plant type of modules, 530, 540 watt, even jumbo size of modules on the 600 watt you can do. So that means PERC is not limiting you in your module size and in your module approach. So why an integrated factory is meaningful? What is integrated factory? Integrated factory means, on our definition, you should include at least 2 segments of the value chain in your factory, in your new factory, gigafactory. So of course, modules should be included because that is the access to the end customer market, the door to the end customer market. But to be honest with you, you should also include cell into your portfolio. So cell and module should be integrated. Of course, if you have deep enough pockets and you want to be totally independent from other guys, you also can include ingot and wafer factory into your portfolio and in your factory. And then it's an ingot, wafer, cell, and module factory. And you can see a photo, a snapshot from our Kalyon PV 1.2 gigawatt factory, which is ingot, wafer, cell, module, training center, R&D center, warehouse included, and even you see the power plants on the roof. So what is the advantage of an integrated, vertically integrated factory? First of all, you can share facilities, utilities, building. That means you can save costs, investment cost. Then you do, of course, you have an easy attempt to optimize your process. Because, for example, like we do at Kalyon, we have very high recycling rates on the ingot and wafer factory, because we can optimize ingot production, wafer production, cell production, module production, and optimize it, and improving our cost structure, our quality. And that is very important, because that sector is going so tight to costs. So that means you have to optimize your production process continuously. But if you don't have, for example, an ingot and wafer factor on in your portfolio, then you have to feed back to your wafer suppliers. Can you do? We want to cut thinner. We want to do thinner wafers, and that always takes a lot of time, and that time is not available. Then, of course, transportation, because if you have an integrated factory, at least the cell and module or ingot wafer cell and module, you don't have in between the factories transportation risks. And since you have you're making your own quality control in between the factories, you know exactly what quality you can get. And then you can control the whole production over the full production. And if you want to do product development, as I mentioned before, you can do it smoothly. Later on, I think this type of approach, it's working for 1 gigawatt, 2 gigawatt, 4 gigawatt type of factories. But if you want to jump higher, because we need these hundreds of gigawatt, I will talk about mega gigawatt integrated factory at the later stage in this presentation. So first, what you also need, my friends, is if you want to make a big factory, you need, of course, automation, because you have thousands of workers, and they have to be how shall I say, supported by an factory automation. So you have hundreds of machines, thousands of machines. So first of all, you should have in the factory automation, and there are very good systems available, HEV systems available. And at the same time, when it's you should also have a manufacturing execution system. All your machines, like we do it at the Kalyon factory, should be connected to a manufacturing execution system, controlling every second the machine status, the throughput, the quality, the uptime of the machine, to orchestrize your big orchestra of your integrated gigafactory very smoothly. And of course, if you have an MES system, you can play, you change some paste and you see immediately the results based on your manufacturing execution system. If you have also the capability, you can also look at tracking capacity supported by manufacturing execution system. That means you can track from the ingot production to the pre-production, made a wafer out of it, made cells of it, based on physical wafer tracking, virtual wafer tracking, batch tracking. So you always can see the flow of your product, and later stage, when you implement your modules in the power plant, you can always trace back if there are some customer reclaims coming, or on the other side, you can optimize your product and you see the impact at the later segment of the value chain. Good, as I mentioned to you, these multi-gigawatt factories, they should be highly automized. So we are strongly recommending, at least at the later stage, to upgrade the factory, including HEV transportation. HEVs, vehicles, moving the trolleys between the machines and the goods between machines. They're not expensive. For a typical size of automation, it's less than 4% of the capex, but you can reduce the workforce by about 20%. And of course, since these HEVs don't have a tea break, they don't have holidays, so they are moving, and they can increase also your uptime very effectively. And then, of course, as I mentioned before, the manufacturing execution system gives a continuous feedback on uptime of the factory, yield losses, and so on. So that high degree of automation, including manufacturing execution system, that is a way to go for multi-giga factory. And I believe in the next stage of development of multi-giga factories, integrated factories, we also will see, how shall I say, intelligent machines, self-learning machines. Artificial intelligence will move into our gigafactories, and that is something which should come. And also, if you have the chance, like in utility or in ingot production, to have a centralized control system to control if you have a big number of the same machines or complicated type of arrangements, like in a typical factory utility, you should also have a control center. That means from a centralized position, you can program your individual machine and monitor your individual machines. So we call it control center. That is available already for ingot factory and for utility system. For cell, it might still make some time, and for wafer, it might take some time. Good. Then, all is not working, my friends, when you don't have the supply chain available. And if you are establishing a new type of fabrication, like we did in Turkey, you have to develop local supply chain, because it has so many advantages. If you can get the glass locally, if you can get the aluminum frame locally, if you can get the foil locally, that of course reduces your transportation cost. And also it reduces working capital, because you don't have you don't have to make big warehouses and buffer stations and spend a lot of capital on working capital. And then now I'm coming to the discussion about the mega gigafactories. It sounds a little bit strange, which means 5 giga, 10 giga type of integrated factory. And that factories should include also the key BOM material. So if you are planning to make a 5 giga plus factory, you should involve glass factory, frame factory, encapsulation fabrication, crucible fabrication, hot zone fabrication into your factory site. And if you have deep enough pockets and you believe you can run the show, polysilicon production, even metallurgical silicon production can be considered at your factory place. Because if you have control of most or nearly all cost matters, then you are totally independent. You can control your cost, you can monitor your cost, and you can predict your cost. And if you are in this 5 giga plus, your demand is big enough to argue to have such type of material factories as well. And then never forget sustainability. We need to make our factories sustainable, which means we have to recycle the products. We have to take care on our waste. We have to make green manufacturing. We have to look at CO2 carbon footprint in our factory. As we do in the Turkish factory, all the roof is covered by solar modules, which gives already quite a portion of our power consumption by solar electricity. So please don't forget the sustainability of your power plant, of your factory. That is important to say. Good. Now, general picture clear. Things are more or less understood. Now let us look how it is done. As I'm also CTO of Kalyan PV, that is an integrated factory located in Turkey, Ankara, so very close to the capital. And we are currently running at the 1.2 gigawatt capacity. And that is one of the largest non-Asian factories, I think, existing. And I will give different introduction, factory layout, key performance numbers, research and development, and also the connected power plant. So first of all, Kalyon. Kalyon is one of the largest construction companies in Turkey. They have 35,000. We have 35,000 employees, and we are in the Istanbul airport as an operator, and the construction company, and big infrastructure programs, projects are done by Kalyon. So now looking at the factory. So spending so far $475 million altogether, 100,000 square meter of factory area, production area, capacity 1.2 giga, domestic production and domestic content. Even now we are above 80%, which is quite high on the domestic and local content. We have 2,000 people working, and a research and development center for future innovations. So as I mentioned, this factory is already showing the vision of an integrated, this factory even under one roof. Not necessarily you have to make all under one roof, but if you do it under one roof, it's of course very nice. But under one roof, you can make perhaps up to 2 giga, but then the roof and the building might be too big. Then you might have to split it in ingot factory building, wafer, cell factory building. Ingot and wafer you can put together. So this is an integrated factory under one roof, including R&D facility and training center. So we are growing our own CZ ingots. We are cutting our own wafers. We are making our own cells, and we are making our own modules. This is how it looks like. This is a photo. Ingot factory is over there. Wafer factory, utility. You see, utility is a big issue. And then you see the warehouse, R&D facility included in this factory, main office building, module factory, and cell factory. So all this is under one roof, all the different segments of the value chain under one roof. And also dormitories. And then the area is big. We have about 100,000 square meter for main building, utility, waste trade, bin, and others. And the capacity 1.2, more than 1.2 gigawatt cell, 1.1 for the module, and ingot and wafer, we are now at 760 megawatt altogether. So what is the product portfolio? We can grow boron and gallium doped p-type ingots, but as core, of course, to already learn about n-type, we have grown n-type ingots in our factory in Ankara, and they were qualified by ISE in Constance as a good quality ingots. Then we have also wafer fab factory. We are now running G1 and M10 wafer format in our wafer factory using diamond wire saw. The wafer thickness we are currently using is a 170 micrometer. We are making mono PERC cells, bifacial ones with a 70% bifaciality factor. Efficiency is typically 22.3+% based on Western measurement standards. So there's a little bit of difference between Chinese and Western measurement standards. It would be 22.6 if you take Chinese measurement standards into account. And of course, we are a little bit on the lower side because we are optimized recycling everything together. So we are sacrificing a little bit in efficiency, but gaining on the cost for watt peak. Then we are making glass, frameless, framed, 500, 400 watt G1, 144 cell half cut, M10, 180 cell, 530 plus watt modules, single facial, bifacial. So we have the whole product portfolio for residential, commercial, and power plants. Okay, so there are a lot of details. I can jump over it. So then the R&D center, of course, if you have such an investment, which is big, you need to always continue in innovation. So we have 100 researchers working at the factory integrated research and development center, and we have 2,500 square meter of research and development facility, including inspection, including process, and we are applying Industry 4.0. All the factory is totally connected to a centralized MES system. And the utility even has a control room approach with a bidirectional guidance. Then there are some R&D studies which are done. So pushing up efficiency, reducing the consumption in ingot and wafer by increasing recycling rate. And of course, different types of modules we are developing. And Industry 4.0 is taking more and more into serious, including building SCADA system and building MES system. And we are also, of course, we are entering now in electric vehicle. So we are now sending charging station, car charging stations to Turkish clients. Training is very important because these 2,000 friends and colleagues have to be trained. So we have an own Kalyon Academy integrated, a full-fledged training center integrated, which is doing classroom training, hands-on training in the production line. And for next year, we have the plan to open this training center for the global society to benefit from our learnings, coming to our Ankara factory, joining the lectures, because we want to have this knowledge shared with the rest of the world. So next year, all of you will be invited to join our training program and to come to Ankara. So then the key performance numbers, they are normally not shown in any presentation from our competitors, but we are an open-minded company. So these are the some KPIs which we have checked very accurately at the factory acceptance test. And you see the yield numbers in ingot, wafer production yields, cell production yields, numbers which are normally not shown. And here you see the cost split. So, of course, you immediately see most of the cost is in material. You can say about 80% of the cost is within the material. So this is why I strongly recommend to include step-by-step also own material production, bill of material production into your portfolio. Then we have, as I mentioned, Turkish and European content in our cost is about 80%, more than 80%. And the assumption for this as cost assessment are shown here. We are doing, of course, crucible recharging. So 4 times recharging is used for our ingot growth. Here, now the big issue comes, how fast you can do it. Is it taking 5 years, 10 years? How long it will take to make a 1 gigafactory? And since Kalyon is a very strong company in executing projects, after contract signature with the Chinese and some Western machines contractors, we have then just a moment. Yeah. 9 months after the contract signature with the Chinese company CTC, we have 9 months after we got the first ingot out, 9.5 months later we got the first wafer out, 9.5 months we got the first cell out, and 8 months later we got the first module out. So you see, if you take the decision, you can do it fast. You don't have to wait 2 years, 3 years. You can do it within 12, 18 months. Your gigawatt factory is working. And these are true numbers. This is not dreaming. And that can taken as a reference. And we even had Corona in this time period. So now as a last, all these modules in the past, not for next year, move to the own connected power plant, because Kalyon also has now started to prepare 1.3 gigawatt power plant, which is one of the largest outside Asia. So we are investing currently $1 billion in a 1.3 gigawatt DC power plant, and from until end of this year, all modules went into our own power plants, what we have produced in our factory in Ankara. And from next year on, we will sell to European, US, and Turkish market. About half of our capacity will sell to outside. So this area is huge. It's 20 million square meter, and it's located in Karapana, which is in central Turkey. And here you see some photos from the power plants. So far, we have finished more than 600 megawatts, 650 megawatt already have been finished. You can say half of it is finished. And the single axis tracker technology is used. And we are using bifacial modules, glass modules, in our case, frameless, because we found out it's much easier to be cleaned naturally as you have the frame, and of course you save cost. And 2 million people are electrified by the huge power plant. We also have a SCADA center, a very modern SCADA center integrated to guide and optimize the power plant and the tracker movement using big data monitoring. These are some more details on the inverter. On the layout, we have 2 substations we are using. And as I mentioned to you, we have nearly finished half of the power plant is concluded. We are using centralized inverter on the 3.7 megawatt size. And finally, we will send about nearly 3 million, a little bit more than 3 million modules to this power plant. And I like to see it. It's so beautiful. It's like an ocean of panels in Turkey. Thanks a lot, my friends, for your attention.
Very nice, Peter. I think ocean of modules, that sounds great. We will have many more oceans in the future. Since we're still delayed, I think, and we still have time during our fire chat later on, I would say we skip basically the Q&A part. If you are still with us, Peter, until the fire chat, you might want to answer some of the questions if there are any in written form in the chat. Huh? Yeah. Okay, super. Then